Let's say we turn on monitor mode for our Wi-Fi card. Then the question that we would have next is, what would be a good way to see the incoming frames? Because we're going to be seeing lots of different frames as we have monitor mode turned on. Wireshark is a popular and powerful tool that lets us inspect the frames that are coming in, and it works perfectly with monitor mode as frames are captured from different Wi-Fi networks around us. It will display the frames and a lot of useful information about the headers and the contents of these frames. We will now demonstrate the use of Wireshark after we have turned on monitor mode. In fact, we're going to see the difference before monitor mode is turned on and after monitor mode is turned on. Let's explore more on monitor mode and the differences between monitor mode and managed mode. So let's first take a look here and confirm that we are in managed mode. So in managed mode, we are operating as a normal Wi-Fi network interface card would, and we're not seeing much of what goes on around. We can do scanning, which is what a normal Wi-Fi NIC card might do, but we can't be capturing a lot of traffic that's going on between access points and the stations. So let's, rather than just believing what I say, let's take a look. When we start Wireshark and we're in managed mode, let's see what we can see. Wireshark is starting. So it's a network analyzer. It's not specific to wireless, but it's okay. Now, since I'm running as root, I would get this warning because generally it's not good to use it as super user, but anyway, it should be okay for our purposes. Now, we see that we have to choose a network interface that we wish to be capturing traffic on and monitoring. There is no WLAN 0 in this list. Let's see if perhaps it's because WLAN 0 is not up. Indeed, we see that WLAN 0 is not listed in the interfaces here. So no problem, we just turn it on. And we do that by using ifconfig WLAN 0 up. That brings it up. So now it's listed here and we see WLAN 0. Double click on it and ooh, there's nothing that we can see here. Well, generally it's not so bad. If the station connects to an access point, then we would be able to see something, but that will be very limited because it would only be its own traffic to the access point, and so not very helpful for Wi-Fi penetration testing. Let's consider now if we change this to monitor mode. How do we change it to monitor mode? There's several ways to do that. Let's try. One is arrow dump ng. An interesting thing about arrow dump ng is that it will not operate in managed mode, so it will automatically turn on it will automatically turn on managed mode for you. That's a useful side effect that it has. In fact, let's verify once again that we are in managed mode. Then we do arrow dump ng. We need to specify the interface. Arrow dump ng WLAN 0, and Wireshark tells us that this network adapter is not running anymore because what happened was that it turned on monitor mode, as we see here. So for a very short amount of time, WLAN 0 was unavailable. That's why Wireshark complained. Now we look at ifconfig, we see that yeah, it's there, it's up. And in fact, it is up because when we look at arrow dump, we see that it's capturing data from various surrounding access points. We see that here. So it's in monitor mode, it's capturing data from surrounding access points. Coming back to Wireshark then, since it lost the capture, no problem, we started again on WLAN 0. And by the way, since we started monitor mode on WLAN 0 using arrow dump ng, which did that as a side effect. It didn't create a virtual interface such as WLAN 0 mon, which airmon ng would have done. So depending on the way that we turn on monitor mode, there's different behaviors. With airmon ng, it creates that virtual interface for our convenience so that we are very sure that that's in monitor mode. With arrow dump ng, it just turns on monitor mode for the existing physical interface and doesn't bother creating a virtual interface with a different name. But no big deal. So here we see the amount of data that is captured. So all these frames that are coming in to Wireshark, and then we can look at these and see what's in them. Request to send, clear to send. These are some of the control frames that are used in Wi-Fi systems because there are multiple stations that are connecting to the network through an access point. So it does this for medium access control. Anyway, that's a whole other topic about how the MAC protocols work in Wi-Fi. It's very interesting too, but it's not really relevant for our purposes for today. So anyway, we see all these frames going between access points and devices. We see that Wireshark understands MAC addresses to have certain prefixes, meaning that they are manufactured by certain vendors, because the different vendors are assigned MAC addresses in certain ranges of the address space. So it automatically interprets that for us, TP-Link, Apple, and so on.